Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of electronic circuit. And in this electronic circuit we are discussing the displaying devices. In the displaying devices we have discussed the many display devices like CRT, like plasma discharge tube, and now we will discuss the liquid crystal display, that is also called the LCD, that is a liquid crystal display. The full name is the liquid crystal display, and in the short we can say it is a LCD, and it is a passive device, which means that it does not deliver any light to display characters, animation, video, etc. So LED uses the fluorescent tubes to lighten the picture but cannot provide a clear picture as LED delivers. But before discussing the liquid crystal display, we discuss what is the liquid crystal. Basically, liquid crystal is the state of matter whose properties are in between those of the conventional liquids and those of the solid crystals. That's why it is called the liquid crystals. For example, a liquid crystal can flow like a liquid, but its molecules may be oriented in the common direction as in a solid. That's why it is called the liquid crystal, as its liquid crystal can flow like a liquid, but its molecule may be oriented in a common direction as in the solid. There are the many type of LC phase, liquid crystal phase, which can be distinguished by their optical properties or by its textures. The contrasting textures arises due to the molecules within one area of the material, and that is called the domain. Being oriented in the same direction as like a solid, but they are different area having the different orientations, means a particular area, in the particular area the direction of the molecules will be the same. That's why it is a liquid crystal, but they are oriented differently. And LC material may not always be in an LC state of matter, just as your water may be ice or on the vapor phase. Liquid crystal can be divided into three main categories. For the brief idea, we will discussing that liquid crystal which we are using in the construction of the liquid crystal display devices. So they are divided into three parts. First is the thermotropic, second is the lyotropic, and the third is the metrotropic. So these are the three form of the liquid crystal, and thermotropic and the lyotropic liquid crystal consists mostly the organic molecules, although a few materials we will know known inorganic molecules. But in case of the thermotropic, LC exhibit a phase transition into a LC as the temperature changes. As the name suggests, that's why it is the based upon the temperature, that is a thermotropic. But other two, if we talk about the other two, like the metrotropic and the lyotropic, they both are made of the organic molecule. In fact, the lyotropic LC exhibit the phase transition as a function of both the temperature and the concentration of the molecules in the solvent. So how they are different from the thermotropic, as in the thermotropic it exhibit the phase transition and the temperature changes, but in the lyotropic it depends upon the concentration of the molecules in the solvent. Basically we take the water. Next is the metrotropic. LCs are compared of both organic and inorganic molecules, and their LC transition additionally depends on the inorganic organic composition ratio. Hence the liquid crystal basically is that state of matter whose conventional properties are in between those of the conventional liquid and the solid crystal. right? And the next, they are oriented as in the common direction, but in the different areas. Another, they are divided into three parts. First is the thermotropic, second is the lyotropic, third is the metallotropic. As the thermotropic depends upon the phase transition and into a LC phase as the temperature changes. Other, lyotropic, which exhibit phase transition as a function of both the temperature as well as the concentration of the molecules in a solvent. Third is the metrotropic, which composed of both the organic or inorganic molecules. Their LC transition additionally depends on the inorganic organic composition ratio. So, these type of liquid crystal is used in construction of the liquid crystal display devices. So, liquid crystal display is the flat panel display that based upon the flat panel display technology. Mainly we will use it in the TV and the computer monitors. Nowadays we are using the mobile phone also, as it is most of the mobile phone uses the LCD display. Now these LC are completely different from that of the old CRT displays, and it uses the liquid crystals instead of the cathode ray in its primary form of the operation. It means that the liquid crystal uses the totally different from the CRT, as it is different. It's different as the liquid crystal display uses the liquid crystal instead of the cathode rays as used in the CRT. So, liquid crystal display consists of millions of pixels made of a crystal and arranged in a rectangular grid. In the LCD we are having a millions of the pixel, and these pixel are arranged in the rectangle grid, and in the LCD it has backlights that provides light to the each pixel. It means we are having a backlight behind the pixels. We are having a lights, and that light provided to the pixels. That's why pixel will glow accordingly. So each pixel has a red, green and blue. That's why it is called the RGB. Such pixels that can be tuned on and off, means whenever we require to glow the red picture, then that red pixel, then the light will given to the red pixel and it will glow. It means it may be turned on, off and off according to its requirement. When all the sub pixels are turned off, then it's black, and when all the sub pixels are tuned on 100%, then the screen will be the white. So when all the pixels are off, all the lights are off, then the sub pixels are turned off, then the screen will be black. When all the sub pixels are tuned on the 100%, the screen will be the white. So you can see on the screen that we are having this type of framing, and here what we are having, you see there are a rectangular arrangement of the pixels, and we are having the millions of pixels here, and these pixels are in the color of the red, green and blue. And you also have seen in your house that these type of flat panel display nowadays we are using for the monitors of computer monitors as well as for the TV screen. LCD is a combination of the two state of matters like solid and liquid, as it is based upon the liquid crystal technology. So the solid part is a crystal, and the liquid part and this liquid part and the crystal together make a visible image. It means it is having a liquid, the solid part is a crystal, and this liquid and crystal together make a visible image. So LCD consists of two layers which are two polarized plane. One is the solid and one is the liquid. So filter and electrode. So LCD consists of two layers which are two polarized planes, which are the two polarized planes. One is the filters and second is the electrodes. So LCD screen works by blocking the light rather than emitting the light. So, we are having a filter and electrode. The filter will filter the light and electrode which will illuminate the light. So, there are the two type of the pixel grid in the LCD. What are these? Number one is the active matrix grid, and this is a new technology. Today's smartphone with LCD display uses this technology. Next type of technology is the passive matrix grid. It is an older technology. Some older devices uses this technology in detail. So, first is the passive matrix LCD, which uses a simple grid to supply the charge to a particular pixel on the display. In this type of passive matrix, the charge to the particular pixel will be given for displaying. Creating the grid is quite a process. Creating a grid is quite a process where it starts with the two glass layers, and these glass layers are called as the substrates. Next is the one substrate is given common columns and other gives the row, made from the transparent conductive materials. We are having a two substrate, one substrate give the column, another substrate give the row, and they made from the transparent conductive material. So, they are usually made of the indium tin oxide. The row or column are connected to integrated the circuit that control when the charge is sent down a particular column or the row. Both are connected in an integrated circuit. In the liquid crystal material is sandwiched between the two glass substrate. It means we are having the liquid crystal in between that rectangular portion which are made from the horizontal and vertical arrangement of the glasses. So, the liquid crystal material is sandwiched between the two glass substrate, and a polarizing film is added to the outer side of each substrate. Just the polarizing film will be coated on the each substrate on the each glass plates. So, to turn on the pixel, integrated circuit sends a charge down the correct column of the one substrate and ground activated on the correct row of the other. It means what we are doing that just we turn on the pixel. As we turn on the pixel, so what happened? Integrated circuit sends a charge down to the correct column of the one substrate and ground activated on the correct row of the other. It means through the integrated circuit or through the current which supply to the substrate on both the side, one at the column and another for the row for the ground. So, the row and column intersect at the designated pixels. So, and that delivers the voltage to untwist the liquid crystal at that pixel. So, through this column and row intersect, it designates as a pixel, and that point delivers the voltage to the untwist the liquid crystal at that pixel. So, the simplicity of the passive matrix system is beautiful, but it has significant drawbacks as it is having the slow response time. Moreover, imprecise voltage control. Because of that, it is less used in the construction of the LCD. Response time refers to the LCD ability to refresh the image display. So, it takes the time to refresh the image, as because it is having a very slow response time. So, the easiest way to observe the slow response time in the passive matrix LCD is to move the mouse pointer quickly from one side of the screen to the another side. So, many times if we pointer will move or the mouse will move, it will notice a series of the ghost following the pointer. So, imprecise, if we talk imprecise voltage control, hinders the passive matrix ability to influence only the one pixel at a time. When the voltage is applied to one twist one pixel, the pixel around it also partially untwist, which make images appear fuzzy, lacking in contrast. So, because of the two drawbacks, one is the response time, slow response time, second is the imprecise voltage. It is having the less usage in the construction of the LCD circuit. So, apart from that, another type of the LCD matrix is the active matrix display, and it depends on the thin film transistors like TFT. And you all have listened about the TFT, thin film transistors, that we use in construction of the electronic devices. So, basically TFTs are the tiny switching transistor and the capacitors. So, they are arranged in a matrix on a glass substrate. So, in the active LCD, we use the TFT. Basically, these TFT are the switching transistor and the capacitor, and they are arranged on the matrix on the glass substrate. And to add a particular pixel, the proper row is switched on and the charge is sent down the correct column. So, all the other columns that the column intersects are turned off. So, a particular point where the pixel will glow, the charge will be given to that pixel. Only the capacitor at a designated pixels receives a charge. So, the capacitor is able to hold the charge until the next refresh cycle. So, if we carefully control the amount of the voltage supplied to the crystal, we can make it untwist only enough to allow some light through. So, how it is possible? This is possible by doping this in very exact, very small increment. LCD can create a gray scale. Most display today after 256 levels of the brightness per pixel. So, these were the two active and passive, display, active matrix, liquid crystal display device, and previous one was the passive matrix liquid crystal display devices. Apart from that, there is a color LCD that can show the color, must have the 3 sub-pixels with the red, green and blue color filters to create the each color pixel. And through the careful control and variation of the voltage applied, intensity of the each sub-pixel can range over the 256 shades, and then we can get the colored screen because of this color LCD. But there is a careful control and variation of the voltage applied to a particular pixel, and we are having the 256 shades in it. Combining the subpixel produce a possible palettes of 16.8 million colors. That means 256 shades of red into 256 shades of green into 256 shades of blue. So, we are having the 16.8 million colors on the screen and the pixel. You see here is the red, green and blue, that is a 60 into magnification. So, these color displays take a enormous number of transistors. For example, a typical laptop computer supports the resolution up to the 1024 into the 768. So this is a high resolution. So if we multiply the 1024 column by 768 rows by the 3 subpixel, as we are having a 3 subpixel like red, green and blue, we get the 2359296 transistors etched onto the glass. So if there is a problem with any of those transistor, it creates a bad pixel on the display. If one transistor will not work, then all the screen will be not will be in the proper manner. So most active matrix display have a few bad pixels scattered across the screen. So in LCD technology is constantly evolving. So LCD today employ the several variation of the liquid crystal technology, in which they use super twisted pneumatics, that is STN. Second is the dual scan twisted pneumatics, that is DSTN, and ferromagnetic liquid crystals, that are the FLC, and surface stabilized ferroelectric liquid crystal, that SSFLC. So continuously the technology is upgrading. LCD technology is constantly evolving, and there are many variation in the LCD, and there is a various parameters that can enhance the performance of the LCD. So next point is the display sizes. It limited the quality control problems faced by the manufacturer. So simply put, to increase the display sizes, manufacturer must add the more pixel and transistor in it. So as they increase the number of the pixels and the transistor, they also increase the chance of including the bad transistor in a display. So if we increase the display size, so number of transistor will increase, and if one is destroyed, then there will be the chances of destroying the images. You see, the manufacturers of the existing large LCD often reject about the 40% of the panels that comes of the assembly line. You see that the white, yellow and images, these are the 60 into magnification, and then that there must be chances of the blood. So the level of the rejection directly affects the LCD prices, since the sale of the good LCDs must cover the cost of the manufacturing, both the good and bad one. Only advances in the manufacturing can lead to affordable displays in the bigger size. So how we create a LCD, you see on the screen how we will create the LCD on the screen. So we will discuss in the next lecture how we will create the LCD. Thank you very much.